All right, we are going to be comparing Module 1.2 to Module 1.3. We're going to start with Module 1.2. So if we look at the beginning, this would represent our start value. We had 1 dot at time 0. Then we added 4 dots at 1 minute. And then we added an additional 4 dots at 2 minutes. So each time we add 4 dots. And what that means is we're talking about an arithmetic sequence. Okay, so let's go ahead and fill out our table. We already know that we are starting at the beginning, which is time 0. Then we have 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes. The number of dots at the beginning at time 0 is going to be a special value. It's our start value, and we have 1 dot. So in our recursive table, we are always beginning with 1. Then, after each minute, we add 4. So after 2 minutes, we've added 4 twice. At 3 minutes, we've added 4 3 times. At 4 minutes, we've added 4 4 times. The number of dots each time is increasing by 4. So 1 plus 4 is 5, 9, 13, 17, 21. In a recursive equation, that's going to leave us with f of n equals f of n minus 1. And that's going to be true every time for a recursive equation. Our action, in this case, was plus 4. So we'll add 4. We have one piece of the 2 pieces of information. The other piece is a start value. So in this case, f of 0, we had starting at 1. So f of 0 equals 1. In our explicit equation, we're going to have f of n equals our start value, which is 1, plus, and we're going to add 4. And the number of times we add 4 related to our start value. So for example, we added 4 1 time at 1 minute, 2 times at 2 minutes, 3 times at 3 minutes. So that's going to directly relate to our n value. So we're going to call that just n. So now, before we graph, I'm going to go and do the same thing for Module 1.3. In Module 1.3, at the beginning, we had 3 dots. And then what happened is at 1 minute, we now have 6 dots. And what happens at 2 minutes is we actually have 12 dots. So what we're seeing is a doubling pattern. So from 1 minute, we're multiplying by 2, then multiplying by 2. And that's the growth pattern. So this is an arithmetic sequence, or sorry, geometric sequence. All right, so we have at the beginning, which is going to be at 0 minutes, 1, 2, 3, 4, 5. We started, though, with 3 dots. So our start value for this is 3. And then we are doubling it, so we're multiplying by 2. So each minute we multiply by 2. And our answers, 3 times 2 is 6, times 2 is 12, times 2 is 24, times 2 is 48, times 2 is 96. So a recursive equation is just like the other one. It always starts with f of n equals f of n minus 1, and the action this time is to multiply by 3. Or sorry, multiply by 2. Our start value is f of 0 equals 3. Our explicit equation is f of n equals our start value, which is 3, times 2. So now we're going to say how many times we're multiplying by 2? Well, here it's 1, 1. It shows up twice, 2. It shows up 3 times, 3. So it's directly related to n. And repeated multiplication we write as an exponent. So 2 to the power of n. And then we could simply graph these. So when we graph 0, 1, so for our linear 0, 1, and then we're going to do 4, 17. So 4, 17. In a linear equation, your graph is a straight line. In the geometric equation, 0, 3, and then we do 1, 6, and then 2, 12, and then 3, 24 is already off of our graph. And you can see it's a curved line. And that's comparing an arithmetic and a geometric sequence.